Hey everybody, so we are now into part 3 of the review in which we're going to have to use trigonometric ratios to find missing side lengths. Added to this is also finding the perimeter, but please understand your test will have you find single side lengths and also sometimes find perimeter. Those are two separate problems. So we have a very straightforward setup. We have a right triangle, we have a given angle, which we'll probably use as a reference angle, and then one side length. In order to find the perimeter, which is kind of like the add-on thing, we are going to have to find both side lengths, and so you're going to see multiple opportunities to practice trig, which is ultimately the point. All right, so let's just get into it. This is going to comprise about 19% of your test again. So our goal here is to find the missing side lengths, and then of course at the end find perimeter. Perimeter is again a separate thing. It's just going to be the sum or adding together of all the three side lengths in the triangle. So let's get to finding. So we know our first step is still our first step. We have to identify a reference angle. We could use this angle here that we know is going to be 50. Okay. We know this is going to be 50 degrees because those have to be, by the triangle sum theorem, 180 degrees total for the triangle. But I'm going to use the one I was given. I feel like that's just safer. Once we identify the reference angle, we should now go about labeling our side lengths. So across or opposite of the reference angle, okay, we have the hypotenuse, which in this case is given to be 19. And then of course we have, what color should I use? This is green. And then we have the adjacent side, 80J. Right? And so it looks like we have to find the opposite side and the adjacent side. It doesn't much matter which one we find first. So I'm going to find the opposite side first. Okay. Now this is a classic trigonometric problem, and again, which I'm giving a right triangle with one angle and one side length. And so I'll go into the setup that I'm familiar with. First, let's do some organization. My reference triangle is similar to my actual triangle, which means I have some ratios that I know have to be the same. I'm solving for opposite. I've been given hypotenuse, and so according to Sokotoa, okay, opposite and hypotenuse will give me sine. So I'm going to use O over H for my given angle 40, and that's equal to the same ratio for the actual triangle using the same reference angle. In substitution, O over H is how we see the triangle. The calculator, to pull a value, needs to understand it as sine. Okay. The opposite side in this case is going to be unknown, so I'll keep it as OP. We're comparing to our hypotenuse, which in this case is 19. Okay. So the calculator understands the sine of 40, but if we're going to do calculations, we have to convert that to a decimal. And so if I take 40 degrees, find the sine ratio, that's going to be 0.6428, which of course I'll put over 1 right away so I can cross multiply and solve. Okay, I'm really short of room here, guys, so I'm not going to show the steps of cross multiplying. I'll just jump right to the answer. So my opposite side is going to be 12.213, approximately 12.213. Okay. Now I have one side now. Okay, so it's 12.213, but I still need the adjacent side, and so I have a couple options that I can use to find this third side. The first option is I can just set up another trig problem. I can use the adjacent and hypotenuse. I think that'd be cosine, and I can do the exact same thing I did. Alternatively, I can notice I now have a right triangle with two sides. I can also use Pythagorean theorem. Now, I think the safer of the two will definitely be using another trig problem. Let me move this over just a little bit so I give myself a little bit more room. Okay, it's not going to move. Okay. I think that's going to be the safest. Just move this. It's so weird that I can't just move part of it. Okay, whatever. Anyway, I think the safer of the two is going to be to use trig. So I'll do that first. But I'll try to alternate methods so we can kind of see how all that works. Okay, so I'm going to be a little squeezed for room here, but I still have reference and actual. I'm going to solve for the adjacent side now. Okay, but I still want to use like the setup I have, and so I have the adjacent and a hypotenuse. That's going to be my ratio, A over H. I'm still going to use 40 degrees as my reference, and since the triangles are similar, the same ratio should exist on the other side as well. Okay, now we know it as A over H because we're looking at a triangle, but A over H for your calculator is going to be cosine. We'll substitute the real numbers from the actual triangle. 80J is unknown, so I'll just call it A. Hypotenuse is known, it's 19. Okay, for us to do a calculation, we need a decimal, so the cosine of 40 is 0.7660, which I'll put over 1. Okay, and that's going to be the same as my unknown adjacent side is to 19. Okay. So again, I'm going to solve by cross multiplying, but with my limited room, I'll just report the answer. So the adjacent side is approximately 14.555. Okay, so we should take a moment and make sure this makes sense. So my adjacent side is larger than my opposite. That's okay because 50 degrees across from my adjacent is larger than 40 degrees across from my opposite, so the adjacent should be larger. Both are smaller than 19, which is my hypotenuse, so that gives me good vibes that we're probably doing this properly. Right? And so we have the two missing side lengths. We just need to find the perimeter, which is like the extra part, right? But the perimeter is pretty straightforward. That's just the sum of all three. Okay, so for the perimeter, I'll simply take 19 plus 12.213 plus 14.555. Okay. 14.555 plus 12.213 plus 19, and so my perimeter equals 45.768. Okay? And again, on your test, you're going to see two varieties. One where I just say, hey, find a side length. And so you got some practicing here doing that. But every once in a while, you might see, hey, what's the perimeter of this triangle? In which case, you're going to have to find both side lengths and add them together with the third side length that was given to find your absolute total. All right, let's do it again. All right. So again, trig is going to be the order of the day. We have a right triangle, okay, with an angle and one side length. So first steps first, let us choose a reference angle. Again, I could choose a complement. I could choose a 69-degree angle that's going to be up here. Okay, and I'm getting that by the triangle sum theorem. All three angles have to add to 180. But instead, I'll just use this. So 31, that's going to be my reference angle. All right, and so let's do some labeling. The side that's not touching shall be opposite. The side touching the reference angle shall be adjacent. And of course, the hypotenuse is always across from the right angle. That's my hypotenuse. All right. So again, it doesn't matter what we solve for first. I'm going to solve for opposite again. Okay. So ratios first. I want the opposite. I was given the adjacent, so that tells me my ratio has to be opposite over adjacent using 31 degrees. Okay. And for my actual triangle, again, opposite over adjacent for 31 degrees. Okay. In terms of changing this up, O over A, of course, we know is tangent, where your calculator knows this tangent. And from your actual triangle, we have the O side, or the opposite side, which is unknown, and the adjacent side is given to be 10. Okay, so for the calculation, we now need to convert to a decimal. So 31, the tangent of 31 is 0.6009 over 1 for cross products, equal to OP over 10. Okay, so cross multiplying, getting OP by itself. I have the OP value, the opposite side value, to be approximately 6.009. Okay, which makes sense. It's across from the 31-degree angle. It should be smaller than the 10, which is across from the larger angle. Now we have to solve for the hypotenuse. Now I kind of promised I'd show you both ways, so the alternative to solving another trig problem would be to use the Pythagorean theorem, because we have a right triangle and we have two sides of that right triangle. And so we can definitely use a squared plus b squared is equal to c squared. It's just as good as solving another trig problem, though a little bit riskier. It's riskier in the sense that if you got the OP side wrong, the opposite side wrong, and I use it to solve the hypotenuse, we're definitely going to be wrong. But like, we have to trust ourselves at some point as mathematicians, so let's go ahead and use it. Remember, A and B have to be the two short sides, and so one of those values should be 6.009, which I'll square, of course. The other side should be the adjacent, which is 10. And that's equal to the c squared, which I don't know, but it is going to be my hypotenuse value, so h squared. Okay, so it's time to run some square values. So 6.009 times itself shall be 36.108. Now, okay, that's going to be plus 100. 10 squared is 100, of course. Okay, and that's going to be equal to my h squared value. All right, adding these two together, so 36 plus 108.108 plus 100 is 136.108. All right, and to get h by itself, we just need to apply the square roots. That kills the square because they're inverse operations. And so the h value that I get is going to be approximately 11.666. Okay? Which again fits our overall hinge theorem because it is a hypotenuse and therefore is the largest value. It certainly is the largest value here. All right, one last thing. We need to find the perimeter. Again, that's just a tack on, right? That's an additional thing I want you to find. And so, okay, so for the perimeter, I just add the three pieces together. So 6.009 plus 11.666 plus the 10 I was given. Gives me a perimeter of 27.675. All right. So the remainder of these problems are going to be of the same ilk. I am going to do them on video, but I'm going to break this up into 4 different videos just for the sake of time. And also, if you saw the first 2 and you realize all the rest are the same, you may not need to see me work out the other ones, and that's going to be your choice. Okay, so I'll see you in the next video in which we will tackle, which one are we tackling? We'll find the perimeter of these 2 fine fellows.